So the Music Bricks project is an European project which aims at bringing technologies that is currently in research institutions on music technology to bring them closer to the market and creative users. And this project, it's basically about in events such as the Music Tech Fest, so putting these tools available for hackers so they can play with it. And later, the most valuable ones, or the ones that have more potential, can be later incubated as part of the Music Bricks project, a couple of months, and become either a prototype or later even a product if the project demands it and has potential. So the main idea is to help creative users and also to try to bring technologies that are currently in research institutions closer to the market and to the rich people and to reach music creators in the end. That's the final goal. And I work at a research lab at the Pompeu Fabra University in Barcelona. We develop a lot of technology. We spend a lot of time working on research, developing all the time new things, but sometimes they're kept in the drawer, and we're making the drawer larger, larger, larger. But it's more important than making this drawer larger. It's what do we do with all these technologies? And at the Pompeu Fabra University, we're trying to bring these technologies closer to users, and we have some success stories of doing that, of bringing these technologies. And I'm going to present today two of these technologies. And I will present how they have been used either for communities, for one public repository of Creative Commons sounds, which is called Freesound, where users can upload sounds to a web repository so that other users can make use of these sounds for their own projects. And another technology, which is an audio processing library to analyze music and audio to extract certain characteristics from the music. You can extract the tempo, the tonality of a song. You can segment a song into excerpts. You can extract a lot of information automatically from music tracks using this library, which is called Essentia. And it's an open source library so that other users can download the code by themselves and play with it, extend it if they want. And I will present these two projects as success stories of tools that were initially were research outcomes, were in the drawer, where we managed to make it publicly available so that other users can use it. Okay, these are the two projects that I will describe today. The first one is this library called Essentia, and the second one will be Freesound. Let's start with Essentia. It's a collection of algorithms written in C++. It's a low-level implementation of audio analysis algorithms that have also Python bindings, which mean that you could, for hackers that are familiar with Python programming, they can use directly the functions of this audio analysis from the Python code in a very easy way, so that they don't have to go down to C++ to work with audio. Basically, we are looking at different type of descriptors. We can analyze timbre, we can analyze time domain or rhythm aspects of the audio. We can extract tonal information, the key, the pitch, the melodic. If you have a song, you can extract the melody, the predominant melody of a track, which usually corresponds to vocals. And you can have other what we call high-level descriptors, such as the mood or a segmentation between the parts of the song, if the instrumentation, and this type of more high-level descriptions. the applications of this library can range from music visualization, so visualizing aspects of the music using this analysis. Indexing, which means if we extract the BPMs of our track collections, we can sort them according to the BPM, so that we can have a list according to how fast the tempo of the music is. We can use music classification. For example, we can classify tracks per genre, or we can do other things like music similarity, like I have a track, find me a similar track to the one that I have, using all these analyses. And with this library has been developed since maybe now 7 or 8 years. And during this journey, it has already, so it's quite a mature technology and has been already integrated in commercial products. For example, it was in VST instrument developed by, commercialized by Steinberg, that the underlying technology was using this audio feature extraction library, Essentia. And in this case, there was like a looping machine where you cut a loop into segments, and then you look at similarity between segments to recompose a track. So you could, if you split a loop into different segments, you keep adding different loops, and you can reconstruct the original loop with segments from the other based on acoustic similarity. So you can What else can you do with this library? And we have another example of an industrial application of this library in a collaboration together with Cork, Japan, in an iPhone app, which is an advanced tuner that gives you information how well you play, not only in how well tuned you are, but whether you play a note, in how stable the note you're playing is. If the attack has some characteristics, so you're looking not only at the pitch and of the information that a regular tuner does, but it gives you more additional information. And this app is called Cortosia, and it's available for mobiles. I can just play also. So the library extracts different characteristics of, as I said, the pitch stability, timbre stability, brightness, etc. So okay. So as you can see, these technologies have already been successfully integrated into M products, but we have more applications, non-industrial applications or more community-based applications, such as acoustic brains, which consist in a collection of crowdsourcing acoustic information so that people analyze their own collection using this library. So we got the analysis, we got millions of tracks analyzed by our library, and the descriptors are uploaded to this acoustic brains service, so that in the end, it's, as a collaborative effort, we have many thousand millions of tracks analyzed, and we can know the BPMs of any track in the world. That's one example. Another example of applications, more collaborative applications, it's freesound.org, that I will give you some more details later on. And this library, this audio analysis library, is used, for example, to find similarity between two sounds in the repository. So you have a field recording of a door slam, and you might want to find similar sounds to that. So using this analysis tool, we can automatically search through the database and find similar sounds. So the basic use cases then are basically the rapid prototyping using, as I said before, the Python binding. So people from Python can already play with the library. Recently, some of the algorithms have been ported in real-time implementation so that they can be used for real-time, for example, in performance, in using pure data or MaxMSP as an object, so that musicians that are accustomed to use these frameworks can use already out of the box this library. And finally, as part of the Music Bricks project, as I started my talk talking about this Music Bricks project, what we plan to do within this project is to provide melody analysis tools, to provide more advanced melody analysis tool as part of this library, and also adding synthesis capabilities. So far we only have analysis capabilities, so we are only extracting descriptors from sounds. And thanks to this project, we want also to extend it with a synthesis capability, so that we can generate sounds, manipulate sounds with the library. Here, just an example of this real-time implementation, and the link where you can download the MaxMSP and Pure Data objects as an example. And as I started, I mentioned that it was an open source code, so it's an open source library, so users can extend it by themselves. They can build their own algorithms, either by combining existing algorithms, so you have an idea how you want to pick a new algorithm based on existing pieces that are already there, or you might want to implement your own algorithm from scratch. So you could use Essentia to build it. And you can think of different building blocks that you can connect and build your composed algorithm. So as a summary, how it compares to existing tools. So the first is that it contains many algorithms. There is a lot of audio analysis algorithms. It not only includes low-level analysis like spectral description of the sound, but it also provides semantic descriptors. So descriptors that as a human you understand whether a song is fast, slow, if the mood of a song, giving these semantic meaningful descriptors. As I mentioned, it has been used also in an industrial context, which is not, it's a rare case in the academia to really make that research tools are used by the industry. We were successful in that. It's still an open source initiative, and now we are trying to push its use in real-time applications, and that's one of the aspects that we want to push within the Music Bricks project. You will find more information in this link in essentia.upf.edu, and the code is available on the GitHub repository that you can find. So this with with regards to this audio analysis library. And the second project that I wanted to talk about is Freesound, which is a repository of sounds under the Creative Commons license, so that it's a collaborative project, so that users can record sounds or produce sounds, upload to this repository so that other users can use. And we provide, so the repository runs on the university servers, so, but we provide not only the infrastructure of this repository, but also an API to access to both the sounds and metadata of this repository, so that you could build your own application. For example, you can build your new mobile application and use the API to retrieve sounds from Freesound. So this is a summary of what is Freesound. Now it contains more than 200,000 sounds, so quite a lot of different sounds. It has more than 4 million users and 65 million downloads. It started in 2005 as part of the ICMC conference. It's a music composition, international conference for music composition and music research. And so it's now its 10th anniversary. So this is the information you get when you search for sounds. You have the description that users provide in form of tags. So when a user uploads a sound, it adds some tags to the sound so that other users can find it later. It's an important aspect of it. It's that these database of sounds are not categorized. It's called an unstructured database in the sense that users upload a sound and they provide tags that describe these sounds. But sounds are not fit in any category, in any pre-established category. It's only the tags that provide a description of the sound. So when you look for a sound, you must search. So you must do a text query using these tags so that you can find the sounds. Of course, we collected sound from all over the world, mainly field recordings, but also musical sounds. We have features of computing similar sounds using this analysis tool, and the API gives you also access from your application to access both to the sounds and to other metadata. So it provides functionalities to search a list of sounds by a query. You can retrieve, you can get user information, etc. And this API, it's fully documented, so that if anyone wants to use it, you can check also some client examples. There are clients in Python, in JavaScript, so you could build easily a web page showing to see the functionalities. And I would just finish making a short demo of what you can do using the API. It's a web page, it's a drum machine that it's automatically filled with sounds from the repository. So now it's filled with percussion sounds. And now it just uses door slams sounds. And there is a drum machine behind it. So, and that concludes my talk.